Hello, welcome back. Today we're going into section 4.4, which is a little review of some of the equation types that we've already seen, only now we are expanding our domain into the set of real numbers. So we'll start with an absolute value. And we'll also look at rational and square root equations. The one major difference that we're going to see in this section again is now we have a domain of R. Okay, so we'll start with an absolute value. The absolute value of the difference of 4x and 5 is worth 1. So the usual absolute value problem rules apply. First, make sure the absolute value has its own side of the equal sign. It does. Then you move on to how many ways can this happen. In this case, absolute value equals a positive number. 2 ways that can happen. So either the argument, the stuff inside, could have been a negative one. Union that up with the possibility that the argument was worth a positive one. Notice this is still a 4x minus 5. The sign did not change. The argument inside is still the argument inside. So after that, we're just solving linear equations in one variable. We have plenty of practice with that from our chapter 2 work. So addition, property of equality, additive inverse, additive identity, and so on. So then we multiply both sides by a quarter, and 1x turns into x, and a quarter of 4 is 1. So this solution we would have kept in either section. Our other one, addition, property of equality, lets us add 5 to both sides of the equation. So 4x plus 0 turns into 4x. 1 and 5 is a 6. Quarter both sides. 1 times x is x. 6/4 is the same as 3/2, and 3/2 is 1 and 1/2. Ordinarily, with the integer domain, we would have had to have discarded the solution. With the real number domain, however, we do get to keep the solution. So both of those go into our solution set. 1 and 1/2. Okay, so next up, another absolute value. Absolute value of the difference of 3x and 2. Close the absolute value, plus 8 is worth 2. So this one, we do have an absolute value problem. It's not, that doesn't have its own side of the equal sign yet, so we do have to fix that before we do anything else. So we'll subtract 8 on both sides. So absolute value of 3x minus 2 is worth -6. Then we say how many ways can this happen? Absolute value equals a negative is impossible, so this one we jump right to our empty set at that point. So even in a real number domain, absolute value is still not equal to a negative number. So that rule still applies. Next up, we'll look at a couple of rational equations. So those were the ones with the fractions. And the key thing to remember here is to identify our excluded values. So we'll start with solving 6 plus the reciprocal of the difference of x and 4 is worth 8. So we can see right away x equals 4 is not going to work for us. So that's going to go in our list of excluded values. Our excluded values, x cannot be worth 4. Our LCD here, our only denominator we see is an x minus 4. The others have an implied denominator of 1. So we multiply both sides by the LCD. making sure to apply the distributive property. So notice everything, including stuff that didn't look like a fraction, does have the LCD attached. What that lets us do is cancel our 1. Since x is not worth a 4, x minus 4 over itself is a 1. So distributing, we have 6x minus 24 plus 1 is worth 8x minus 32, and this one turned linear. So a little bit of simplifying left to do on that left-hand side. Hang on to the right side, and then we're just using the same properties we used back in chapter 2. So I'll start by subtracting 8x on both sides. So negative 2x minus 23 is worth negative 32. Next, we'll add 23 to both sides of the equation. So negative 2 times x, unlike signs. So we will subtract absolute values. The negative had the bigger absolute value. So 12 minus 3 is 9, so negative 9. And then we'll multiply both sides by negative 1/2. 1 times x is x. Negative times a negative is a positive. 9/2. 2 would go into 9 4 times with 1 left over. And again, we would not have been able to keep this back in our integer days, but in the real numbers we do get to keep it. It's not in our list of excluded values, so that will go in our solution set. We do get to keep the 4.5. Okay, a couple more rationals, and then we'll get into our friends, the radicals. Alright, so we'll do next one. Reciprocal of the difference of x and 2 is worth x over 2x minus 4 plus 1. This one I do see a little bit of factoring I can do in that second denominator, so we'll go ahead and do that. Sorry, my pen bled a little bit there. That is just an x and a minus sign there. Alright, so x over 2 times the quantity x minus 2 and plus 1. So now that we have it factored, we can see, okay, our only excluded value here, x definitely can't equal positive 2, and our LCD this time is 2 times the quantity x minus 2. So everything gets multiplied by the LCD. So 1 times 2 times x minus 2 over the original x minus 2 equals x times 2 times x minus 2 over 2 by x minus 2 plus, and don't forget this guy, even though he doesn't look like a fraction, he still gets multiplied by the LCD. So then we're canceling our 1s. 2 divided by 2 is 1. Since x is not worth 2, x minus 2 over x minus 2 is worth 1. And we have that same thing happening on the left-hand side. So left side, 1 times 2 is now just a 2. Right-hand side, x times 1 is x. And distributing the 2, so plus 2x minus 4. So a little more simplifying to do on that right-hand side. So 2 is worth 3x minus 4. So then I'll add 4 to both sides. So 6 is worth 3x plus 0, or simply 6 is 3x, and then we just multiply both sides by a third. So a third of 3x. So 2 is worth 1x, or x equals 2, but notice our excluded value, x cannot be worth 2. So this one is the empty set, no matter what our domain was. Real numbers, any kind of domain, even into the complex. We would not be able to keep 2 for a solution if it would make us divide by 0. Okay, one last one of our rationals before we get into our friends, the square root equations. So we have the reciprocal of x plus the reciprocal of the difference of x and 3 is worth difference of x and 2 over difference of x and 3. So right away, I can see 2 excluded values. So x cannot equal 0, x cannot equal 3. That would make us divide by 0 in the first fraction or in the second two fractions. Our LCD is the product of x and x minus 3. So everybody gets multiplied by the LCD. Now the x minus 2, two terms, so make sure that's in parentheses. All right. So x minus 3 over x minus 3 is worth 1 as long as x isn't worth 3. And x over x is 1 as long as x is non-zero. And we've stipulated both of those points. All right. So 1 by x minus 3 is x minus 3. 1 by x is x. And we have a little bit of distributing to do on that right-hand side. X squared minus 2x. So negative 3 plus 2x, simplifying on the left side, x squared minus 2x on the right-hand side. This one, notice, is a little bit different than the last two. This one turned quadratic. We have this x squared, so different strategy. We want to set one side to 0 and go from there. So I'm going to add 3 to both sides. I'll also subtract 2x on both sides. So then 0 on the left-hand side, x squared minus 4x plus 3 on the right-hand side. And now we know a few different ways to do this. The fastest way is factoring. So if it's factorable, we're looking for two integers that will multiply out to positive 3 and add to negative 4. And sure enough, negative 1, negative 3 will do the job nicely. X minus 1 by x minus 3. So we set each factor equal to 0, union in the middle, and solve each one. So we'll add 1 to both sides. So x plus 0 is x, 0 plus 1 is 1. Add 3 to both sides of the other equation. X plus 0 is x, 0 plus 3 is 3. And we get to keep one of those two. X equals 3 was one of our excluded values. I don't get to keep that one. I do get to keep the positive one. And finally, our friends, the square root equations. So similar to the absolute value equations in a square root equation, first you want to make sure that the square root is by itself. It is, so I don't have anything else on the left-hand side of the equal sign. So I'll undo the square root by squaring both sides. So left-hand side, square and square root are inverse operations, so we get our 3x minus 1, the argument, back. Right-hand side, 5 squared is worth 25. So then we're adding 1 to both sides. 3x plus 0 is 3x. 25 and 1 is 26. Yep, still quarantined with my 9-month-old daughter. She's very, very cute. All right, so a third of 3x is a third of 26. 1 times x is x. 3 will go into 26 8 times with 2 left over. The one additional piece of the puzzle that we had to do on the square root equations, they wouldn't write in the directions that we had to do it, but we do have to know to do it, is we do have to do a check because we still could come up with extraneous solutions. So square root of 3 times 8 2/3 minus 1 is possibly equal to 5. If I'm multiplying with a mixed number, I want to turn it into an improper fraction, and I'll do the same with that 3 then. So this is 3 over 1 times 26 over 3 minus 1, and I want to know, is that worth 5? So root 26 minus 1 possibly equal to 5. Root 25 possibly equal to 5. 5 equals 5. It does work. So we get to keep 8 and 2/3 in our solution set. If we came up with 5 equals 7 or some other nonsense statement, then it would have been the empty set since we only had one potential solution. All right, and our last of the radical equations, square root of the quantity 3x plus 18 is equal to x. Radical's already by itself. If it wasn't, fix that first. So we'll undo the square root by squaring both sides. Square and square root are inverse operations, so we get our argument 3x plus 18 back. X times x is x squared. This one is quadratic as opposed to the last one that was linear. So we'll set one side to 0. Since our x squared has a positive 1 implied in front of it, we'll move the stuff from the left side to the right side. So I'll subtract 3x, and I'll subtract 18 on both sides. So 0 is x squared minus 3x minus 18. Again, we have a lot of tools in our tool belt now to deal with quadratic equations. If they don't specify a method, check for factoring first, and if factoring doesn't work, go from there. So I'm looking for a pair of integers that will multiply to negative 18. 1 times negative 18 is negative 18, and add to a negative 3. And we do have a pair of numbers that will do that. So a minus 6 and a plus 3 will get both jobs done. We'll multiply to negative 18, add to negative 3. So again, we're setting one at a time equal to 0 and solving. X minus 6 is 0, union x plus 3 is 0. So then we're just using those same properties of equality we've been using since chapter 2. So x could be 6, or x could be negative 3. So then we go to check to see if we can keep one of them, both of them, or neither of them. So square root of 3 by 6 plus 18 possibly equal to 6. So root 18 plus 18 possibly equal to 6. Square root of 36 possibly equal to 6. 6 equals 6. That one works, so I know I at least get to keep one of my answers. Now I'll try out the other one. Square root of 3 by negative 3 plus 18 possibly equal to negative 3. So square root of negative 9 plus 18 possibly equal to negative 3. Root 9 possibly equal to negative 3. 3 equals negative 3, though, does not work. That one came from trying out the negative 3. So that one I don't get to keep. The 6 we do get to keep. All right, so that should give you enough information to take care of section 4.4. If you have questions, please get in contact with me. Otherwise, stay safe out there, and I'll see you next time.